In this video, we will create 11 Google Cloud functions. I'll show you multiple ways to deploy functions. We will be using UI, gCloud CLI, Git, Terraform, and at the end, we will build CI/CD pipeline that will be triggered each time you update the function. We will use Node.js and Python to create all of those functions. Some of the cloud functions will be triggered by HTTP requests, some by published messages in PubSub topics, and file uploads to JS buckets. You can find the timestamps in the video description. Also, all the commands that I run in the video and the source code are available on my website and GitHub repository. The link will be in description. Let's create our first function from the UI. Go to the console and click Cloud Functions. It will take a few seconds to enable Cloud Functions in your GCP project. When it's done, click on Create Function. Give it a name, for example, First Function. Then select the region. I'll choose US Central 1, which is one of the cheapest regions in Google Cloud. It's perfect for the demo. There are multiple ways how you can trigger this function. You can use HTTP trigger, PubSub, and others. I'll start with the simplest one, HTTP trigger. You already can see the URL that we can use to trigger this function. Now, if you build in the public API, you want to disable authentication. On the other hand, if you're going to keep this function private, leave require authentication. We will enable authentication for the next Google function. Also, you have a choice to disable HTTPS and allow HTTP as well. In general, you would always want to secure all the communications between your services. Unless you have a specific requirement, keep this option on. Under Runtime, Build, Connections, and Security settings, you can find additional options. We will use some of them later in this tutorial. We will create and use service accounts. Also, we will create API key in the secret manager, and I'll show you how to access it from the cloud function. Let's save the settings and click Next. If you have never used Cloud Build API before in this project, you may get a warning. Click Enable API to continue. Under Runtime, you can select the language that you want to use. I'll start with Node.js and then we will create a few Python functions. To create a function, you can write code directly in the console. You can create a function locally and upload it as a zip archive, as well as you can use gCloud CLI to simplify the deployment process. We will start by modifying the function in the UI. If your function requires third-party NPM modules, you can declare them in the package.json file. Function generated by Google will check for URL query parameter and payload. If none of it is present, it will return hello world. Let's deploy our first function. To invoke the function, click on the first function, then under the trigger, you can find the URL. Copy it and use curl to call it. It should return hello world. HTTP functions can be invoked by different kinds of identities originating in different places. The invoker can be a developer who is testing the function or another function or service that wants to use this function. As a developer, you also likely need to invoke your function for testing purposes. To invoke a function using curl or similar tools, you need to have functions invoke permission. Let's check if my current user has this policy. Go to IAM and admin and then IAM. I have organization administrator and owner role. Let's check if the owner role has this policy. Select owner role and search for functions invoke. Now let's quickly create another function and require authentication. Let's call it secure function. Keep all the default parameters and click deploy. Try to invoke this function using a similar technique. You will get an error. Your client does not have permissions to get URL. To be able to invoke this function, we need to include bearer token in authorization header. You need to have gCloud CLI installed for that. When building services that connect multiple functions, it's a good idea to ensure that each function can only send requests to a specific subset of your other functions. To configure the receiving function to accept requests from a specific calling function, you need to grant the Cloud Functions Invoker role to the calling function's service account on the receiving function. To demonstrate, let's create two service accounts. One for function A and one for function B. In the demo, function B will be invoking function A. In the function, just update the return string to hello from function A. To allow function B to call function A, we need to add function A as a principal. Paste the service account email for the function B. Select the Cloud Functions Invoker role. Next, create another Cloud function and call it function B. Check Allow Authenticated Invocations and select the function B service account. To be able to invoke other function, we need to use Google Auth module to get a token. Then specify the URL of the function that you want to invoke. Suppose you don't have any arguments in the URL, for example, delete ID. Then set target audience equal to URL. Then try catch block. Try to invoke the function and then return the content to the client. If it fails, return error. It may be a security issue to return the exact error, but for the demo, it's fine. Don't forget to update the entry point for this function as well, to invoke function A. Since we're using the third-party module, we need to declare it in the package.json file. Deploy the function and copy the URL to invoke it. Use curl to call function B. It should return hello from function A. You can use Secret Manager to securely store API keys, passwords, and other sensitive information. Let's create API key in Secret Manager, call it API key. If you haven't used Secret Manager before, you may need to enable Secret Manager API. Click Create Secret and give it a name, API key. For secret value, let's use DevOps123. Leave other default parameters and click Create Secret. In order to grant access for our function to access this secret, we need to create a service account and add it as a principal to this secret. Name it secret function. If you want this function to access all the secrets in this project, which is unlikely, you can grant project level permissions. Don't forget to copy email for that service account. Next, add this email as a principal to the API key secret. Use Secret Manager Secret Accessor role. To test, create a new function. Give it a name secret function. Disable authentication. Under Advanced Settings, choose the service account that we just created. Then go to the Security tab and reference the API key secret. For the mount path, enter API. Our secret will be available on API/API key. Now we just need to read the file with the secret and return it to the client. In the function, import fs module. Then, in the body of the function, try to read the file. If it fails for some reason, log the error and return the 500 status code to the client. On success, return the secret. Don't forget to update the entry point for the function. It should match the function that you export. In this case, it should be read secret. When it's done, click deploy. Since it's a public function, we can use curl to invoke it. It should return DevOps123 API key. You also have an option to deploy your functions from the source repository, like GitHub or Bitbucket. But first, you need to mirror your existing repository to the Google Cloud source repository. To try it out, we need to create a GitHub repository that will contain all our functions. Let's give it a name simply functions and make it private. You can add a README file. Clone this repository to your workstation. Create a new folder for the function. Maybe call it git function. Now create index.js file and define a simple function that will return hello from Git. You need to create a package.json file where you can optionally define dependencies for this function. Next, we need to mirror this repository to Google. Go to Source Repositories and create one. Select Connect External Repository. Choose the Google project where you're working on and Git provider. In my case, it's GitHub. If you're doing this for the first time, Google will ask you to authorize them to get read access to your repositories. Let me select the one that I just created, Functions. It may take a few minutes to initialize and mirror your GitHub repository. If you change to the main branch, you should see your function's source code. To deploy that function, you can use GCP console, or let's do it from the command line. Run gcloud functions deploy. Specify the source that will point to the Git repository. For the first time, you also need to specify the runtime, then HTTP trigger and entry point. For the source URL, you need to replace devops by example with your project ID, then the cloud repository ID, branch name, and a file path to the function folder. Let's say you want to make a change in your function. Make a change, then commit and push to your GitHub repository. It should immediately sync with Cloud repo. If it's out of sync, you can go to the settings and manually synchronize repositories. To redeploy, just rerun the same command without runtime and trigger. Continuous integration and deployment CI/CD pipelines help to ensure that your functions work both locally and in a test environment on Google Cloud. Let's reuse the Git repository functions that we created for the previous example. However, you can use any third-party CI/CD services such as GitHub Actions, CircleCI, and even Jenkins. In this video, we will stick with Google Managed Services. First of all, we need to create a new build trigger in Cloud Build. Go to Cloud Build, then Triggers, and click Create Trigger. Name it as you want, maybe Cloud Functions. Then you can choose when you want to run this build. On push, on branch, tag, or maybe you want to run some tests when a pull request is open. For the source, we can select mirror repo, but I highly recommend connecting a new one. I had some issues integrating this Cloud repo with Cloud Build. Select GitHub and click Continue. Then you need to authenticate with GitHub to allow Google to access your repository. Then select the repo that you want to integrate with Cloud Build and click Connect. You can specify what branch name to use. In my case, it's main. We're going to be using the standard cloudbuild.yaml config file, keep after detected. Leave other parameters as is and click Create. If you go to dashboard, you'll see no builds. Now we need to grant some permissions to the cloud build to be able to execute our pipeline. Describe the GCP project to get a project ID and a number. Allow cloud build service account to act as a cloud functions runtime service account. Assign the Cloud Functions developer role to the Cloud Build service account, which allows Cloud Build to deploy Cloud Functions. Next, let's create cloudbuild.yaml file and define steps to execute our pipeline. The first step is to install all the Node.js dependencies. If you have any tests, we can run them next. Finally, deploy a function. Similar parameters to the gcloud CLI that we used before. Let's call our new function CI/CD function. Commit and push to the remote branch to trigger a build. It's possible that it will fail for the first time. In that case, you need to find the issue in the build. It may ask you to enable Cloud Resource Manager API. The build is finished. Let's go to the Cloud Functions and copy the URL to trigger the function. By default, it will be a private function, and we need to authenticate with a token. If you make a change in your function and push it to the remote, Cloud Build will redeploy your new function for you. Some of you may be familiar with Terraform. A lot of companies nowadays manage the infrastructure as a code. In this example, I'll show you how to deploy Cloud Function using Terraform. For simplicity, I will create all Terraform code in a single main.tf file. We can declare local variables to be able to reuse them throughout the code. First is a project ID and a timestamp. We're going to append it to a zip archive with our function. To create resources in GCP, we need to use Terraform Google Provider. You need to specify the project ID and a region. We're going to be using the function that we created in the previous example. For Terraform to deploy that function, we need to create a zip archive and then upload it to the JS bucket. You can use existing bucket or create a new one using Google Storage Bucket Terraform resource. Then just upload the zip archive to the bucket. To trigger redeployment of the function when we change the source code, we also need to change the name of the object. Finally, we get to the function itself. Give it a name, runtime, and you can customize other parameters as well. Pretty much the same set of options that you have when you deploy it from the command line. By default, it will be a private function. You can optionally make it public by allowing all users to invoke it. For our convenience, we can output a function URL that we can use to trigger it. Keep in mind, when you don't specify the Terraform backend, it will store its state locally. This means you have to commit and store it in the Git, or the better approach would be to use remote storage such as JS bucket. Let's run Terraform. First, you need to initialize it and download all the plugins, including Google Provider. Then you can run a plan or apply to create a function. In a couple of minutes, it will deploy Terraform function. We can grab this URL and try to invoke it. In your functions directory, install functions framework library for your language. For the Node.js, run the following command. Before running a function with a functions framework, you first must specify which function within your code should be run. The Node.js functions framework allows you to specify your function's name and signature type as command line arguments or environment variables. You can also override the default 8080 port. Now go to the terminal and run your function. Your function will be available at localhost 8080. You can use curl to invoke it. Cloud Functions uses event-driven functions to handle events from your cloud infrastructure. For example, Cloud Functions can be triggered by messages published to PubSub topics in the same cloud project as the function. Before we're going to deploy a Cloud Function, we need to create a PubSub topic. You can do it from the UI, use gcloud CLI or Terraform. Give it a name, Lesson 106. Next, go to the Cloud Functions section. Create a new one and call it PubSub function. Instead of HTTP, select Cloud PubSub and a topic Lesson 106 that we created earlier. You have access to the same additional parameters. You can adjust memory, timeout, update the service account, and others. For this function, let's use Python. You have main.py to define your function and requirements.txt to specify dependencies. We can leave function as is. It will print the message from the PubSub topic to the log. Wait a couple of minutes till the function is ready and go to PubSub. Select a topic and publish a test message. Now let's check if the function was triggered by this message. You should be able to find the test message in the log of the function. Cloud Functions also can respond to change notifications emerging from Google Cloud Storage. These notifications can be configured to trigger in response to various events inside a bucket: object creation, deletion, archiving, and metadata updates. We need a bucket. Create one and give it a name, Lesson 106. I'm going to skip all of the possible configurations since we just need a bucket to trigger a function. Next, create a function. Give it a name, JS function. Replace HTTP trigger with cloud storage. You can select different types of events when you want to execute your function. I want to run it when the file is uploaded to the bucket. Then you need to specify which bucket to watch. Let's go with Python again, but it does not make any difference. This function simply prints out the file name to the log. I'm going to upload a thumbnail for this video to the bucket to check if it will be triggered. Now, if you go back to the function, you should see the thumbnail v1 message in the log. In the last example, we're going to use Cloud Function as a backend for the API gateway. This example will cover bare minimal setup, and in the next video, we're going to deep dive into API gateway. API gateway requires you to enable the following Google services: API gateway API, Service Management API, and Service Control API. After you have enabled all of them, you can create API gateway. But before, let's create a backend function and two service accounts. The first one will be backend function, and the second one is API gateway. Give it a name, backend function, and select the service account. Leave all other default parameters as is. Let's keep the default Node.js function as well. We also need to allow the API gateway service account to invoke this function with Cloud Functions invoker role. Now go back and create API gateway. Let's name it My Gateway and same for the ID. Then we need to create Open API spec locally. Specify the path hello and point to the backend function. Under Upload API spec, select the config. After API gateway is created, we can use its URL and hello path to invoke our function.